Okay, this is the last video on what we're looking at, different types of languages and how they're converted so computers can use them. The last interpreter is called an assembler. So just to recap, a compiler and interpreters convert high-level language into low-level language, and they both work slightly differently, and that's looked at in the other two videos. There's another type of low-level language. So if you remember our little diagram where we've got a person at the top of the mountain and the person likes high-level languages, and we've got the computer at the bottom of the mountain and the computer likes low-level languages. An example of a low-level language is machine code. Another example of a low-level language is what we call assembly code. Now, assembly code was developed to help humans program in machine code. And sometimes it's really useful to be able to program in machine code because machine code runs much faster because it doesn't need to be converted from a high-level language to a low-level language. This process takes time. Whereas if you write something in machine code, it will run very, very quickly. So we have assembly language. So if I just write out two bits of binary here, imagine this bit of machine code is to store something. This bit of machine code is to load something. So assembly code simply replaces the ones and zeros with some letters. So we have STA for store, LDA for load, and we call these mnemonics. So you might come across that word, it might pop up in an exam question somewhere in the summer exams. So STA is the mnemonic, which means store. LDA is the mnemonic, which means load. And a mnemonic is just a memory device. It's a way of remembering something. So a three-letter word which helps us to remember that STA means store. Now, the assembler, which is the translator we're looking at here, simply takes the mnemonic that the human can write in, because that's easier for a human to remember than the binary, and it just looks up what the machine code would be. So it would look up, in our example here, that we've typed STA. The assembler simply looks up STA, finds that that's the machine code, and then it turns our mnemonic into the machine code. So all the assembler does, it takes the code, the assembly code that we've written, and it converts it straight into machine code. So the assembler is just a translator which converts assembly language into machine code. And this process is very fast because it's much less complex than turning our Python statements into machine code where we were using the compiler and the interpreter. That's much more complicated, taking some Python code that we've written. Here we're just converting these mnemonics straight into machine code. So there's a direct one-to-one translation there. So STA will become that, and those are just examples. Okay, so just to recap, the assembler, it's a type of translator, but the assembler simply takes our assembly code here, which is just our three-letter mnemonics, and it looks up what the machine code value is. So it will then return the machine code value. This is extremely fast, and the advantage of humans is humans sometimes need to program in machine code because you might be writing code for something that needs to work really quickly. So if we were talking about air traffic control software, you would probably want to write that in such a way the code would need to work extremely fast so you can manage all the planes that are circling in your airport. So that code would need to run really quickly. Nothing runs as quick as machine code. Okay, so that's the end of that video. Thanks very much.